honored to present to you our moderator. She's the technology leader for electrification at the research office at truck manufacturer Scania. Here is Tiba Sharifi. Welcome.
Thanks a lot. Thanks for
I'll leave it to you to present your panel.
Yes, it's a great honor to be here, actually, and run and moderate this panel discussion, which is actually has a really interesting title. I'm so excited to introduce our panelists. Rino Fila, Senior Engineer in Electromobility and Energy System at Scania. Rino is working with engineering research and pre-development of sustainable powertrain in a broad context with focus on the system perspective in various zoom levels. Please welcome. John, or I present his name in both ways. Jan Lind, Director for Product Development Component in Xylem. Jan is responsible for the development of components like electric motors for a large part of Xylem products. In addition, he's responsible for the development of Xylem hydraulic part, which has a significant impact on energy use and carbon footprint. Welcome, Jan.
Thank you.
Should we jump into the discussion? I start with you, Rino. Looking at this title, which is actually really interesting, eye-catching, and at the same time, I'm sure that is a bit confusing for all of you. And I want you to reflect on this title. What do we mean by 10 times and not 10%? What we want to, what is out of this? What does that mean?
Yeah, for sure, it's interesting. It's sort of a call to action. It comes from the 10x thinking. That's very much a Silicon Valley thing, but it means that if you're setting out to change the world, don't set out to change it by 10% or 8%. Do it like something transformative, 10 times, 100 times. Because when you're set out to change something by 10%, you probably will reach like 8% and say, call it a day, it's good enough. If you set out to do something 10 times as good, then you realize you can't just do the small things. You can't do it incrementally. You have to take a step back, look at the bigger picture, transform the problem. And if you then fall short and just save the world make the world better 8 times, wow, 8 times is quite a good thing, quite a good number. So that's where the title comes from. And that's what I try to do in my work and what we try to do at Scania. And if I take the example from the transport industry, how do we make it, commercial transport 10 times better rather than 10%? It's obviously not good enough to just look, if you say, take a truck, to say, yeah, we're changing the diesel engine a little bit, perhaps electrify it. But you get this, like you're changing a diesel engine from 45% average efficiency to perhaps an electric motor, 90%. It's just factor 2. You're not getting to factor 10. So what you need to do is to take a step back, zoom out several times. And since we do have some time, I can sort of give you a short intro into this zoom out journey. It's first, you know that engineers are very good at going down into niches and specializing themselves. So you get engineers who are really good at diesel engines, others who are really good at transmissions. What you need to do, you need to understand that they work together as a system, and not only as a powertrain as a system. Step back is really the commercial vehicle, the complete truck is one system. Everything needs to be controlled in harmony, and you need to understand how everything affects everything. That's the first step. And then you need to sort of rotate the problem on its head and realize you can't start with the power source like the engine and how to make it more efficient. You need to look at the consumers. So in a truck, you want to drive forward and you want to probably drive something. Might it be a concrete mixer or a crane or something? So power is consumed. How do we make sure that these consumers get the power they need in the best way? So you start from that end. And then you take a step back and realize, okay, but the vehicle is just one component in a larger system. We have the environment and the driver. We just heard a great talk about what you can do with automating driver, partially or assisting or even complete autonomous, so that there are savings. You can look at the environment and realize that, yeah, sometimes you don't really need all that power to do the work you're supposed to do. You can do it in a different way so that they don't overlap and add up to each other to a huge peak power. You can shift it, or you can do it more efficiently, or you can connect and look, do I actually need to do this? Are there smarter ways to get the same effect, but not by this? So you're sort of connecting it to the actual need of the human being, the customer, or society. And then you take a step back and realize, okay, but now we are looking at just one vehicle, but one vehicle always works together with several in a logistic chain, and the logistic chain is part of production chain. So you're getting to the question, okay, but what does it actually mean? Why do we actually do this? Is it necessary to do this? And then we are into optimization of a complete fleet of vehicles and how to make sure that the transport that is needed to be done is done in the most optimal way. Also the question, is that transport actually necessary? And then you take a step back and you realize you have a transport system, we have an electricity system, and those have evolved separately, and they need to merge. They need to get coupled. And all that journey, you zoom out in all the time.
So if I understood correctly, so I think this multiplication factor comes from a sort of compound effect that you go stepwise.
Yes.
So you don't add up, you multiply by going back and back, zoom out a little bit. So it's exactly compound effect. When you fold a piece of paper, you don't add up the thickness of the paper, you just multiply.
Yes.
Okay, perfect. Is there anything that you want to add?
No, I talked too much already.
Yeah. So I turn to you, Jan, with a quite different type of question, because it's just when it comes to digitalization and energy consumption, how digitalization can play a role in energy consumption, in your point of view?
Well, I think or we can expect power-consuming products to become more efficient over time. That has perhaps little to do with the digitalization, but a good thing, obviously. However, the biggest savings will come by changing the way we operate these products. And most often you find the biggest savings potential by kind of optimizing on a system level rather than optimizing on a component or a product level. Now, if we imagine a system with all of these power-consuming products, and in this system there are constantly ongoing changes within the system, and also the boundary condition of that system is constantly changing. In such an environment, to optimize that, we would need kind of sensors to measure what's happening. We would need to communicate that, and we would need some computer-powered algorithms to kind of control that system to minimize the energy consumption, while at the same time also give the user some useful insights and also kind of actionable insights. And that's kind of digitalization at its core. Now, today with digitalization, we can build system on a scale never seen before. And today it doesn't really matter if these, power-consuming products, where they physically are located, they can even be, scattered around the world. And these kind of systems are often easy to scale up. And definitely, digitalization holds the promise to kind of reshape the energy landscape. Today, the majority of energy is being consumed either in transportation, buildings, or in the industry. And for each of these three sectors, there are multiple examples how digitalization can help reduce the energy usage. And finally, I would say digitalization also has the potential to flatten out the electricity demand curve so that we can kind of avoid these peaks. And the kind of nice thing with that, the benefit being that we can avoid to activate these both costly but also very carbon-intensive power plants that typically are where gas and oil is being used.
Really interesting. My mind got stuck with one phrase that you used. I just take a little bit time on asking this. This boundary condition, you told that it is constantly changing. What do you mean by that?
Yeah, but I think I've tried to be general, but I think in most systems there are things happening. There are like in the industry, I'm working with water sewage networks, that kind of things. You have inflow coming. It suddenly rains a lot. It's 8 o'clock in the morning. Everyone takes a shower. Things are changing that you need to care for, and I think that kind of be applied in most systems. That things are kind of changing, and that system needs to react to it in a smart way. And typically, if we take the trucks for Scania or pumps that I work with, let's say if you have to move a truck from point A to point B, you can do it, run it at 200 kilometers an hour or 70 kilometers an hour. By the end of the day, the same job has been done, but in these two cases, you've wasted a lot of energy probably going by 200. In a pump system, if you're moving water from A to B and you try to do it in a very short period of time, you run it at very high speed, you're bound to have a lot of friction losses along your pipes. It's then better to reduce the speed, you get the same job done, but with a lot less energy.
Oh, great answer, thank you. So now talking about digitalization, I get back to you, Rino, asking this question. Okay, let's say that we are good with the title of this panel. We understood this, but what are the obstacles? If you are thinking about, because we say that through digitalization and electrification. So what are the obstacles?
Yeah, just connecting back to what John said, is faster is not always better. Sometimes a constant flow is much better and more efficient. And that ties to the digitalization as well, and this optimization of logistics I talked about. It's we need to find a flow to get the transport done that you want to be done, and that needs probably a bit more, or quite a lot more, oversight and supervision than what we usually do. I mean, if you look at commercial aviation, for instance, before a plane even departs with passengers, they have done a lot of things in preparation. They have booked the time slot for departure, booked the time slot for arrival. They have filed a flight plan so that all the authorities and air traffic controls along the road know they are coming, along the road, and at what height, and they have checked the weather, and they know if there are any patterns they need to avoid, or they can go straight. They know the amount of wind, they know how many passengers will check in. They have a good estimation of how much luggage there will be, so that means they know center of gravity, roughly, they will control it. They will only get as much fuel on board as actually needed to get to the arrival, plus a safety margin. The safety margin is also planned in case there is something wrong with the arrival airport. We will divert to that airport. So there's a lot of things, and I'm not saying that road transport will ever get to this level of organization, but we need to get closer to it, because it's amazing what you can do if you have this control or details in advance. So if you talk about optimization of logistics for road transport, that will mean we need data, models, and algorithms. And data, that is everything from weather to traffic flow to traffic disturbances, planned or unplanned. That's if you connect it to electromobility, it will be dynamic charging prices, or if a charging station I'm booking, if that's projected to be full when I'm arriving, then I obviously can't use it. A lot of data. Quite some of these data are available today, but not everything. And it needs be high quality and uptime 100%. So that's data. Models. If we want to have that type of control as in aviation on the road, we need good models that tell us or project the range of electric vehicles with a good accuracy. It needs to be done. And to face it, there are other OEMs than Scania in the world, so there will be other brands of trucks as well. and there are lots of different manufacturers of trailers, and they mix all the time. So we need to exchange models in between. So they can't be kept secret, and the parameters can't be kept secret either. So that's a challenge. And algorithms. Actually, if you look at the total problem of I have this amount of goods to be transported, each customer has their own time slots for when you can pick them up and when you have to deliver them. You have dynamic charging prices, you have different trucks, they are configured differently. So many dimensions, it just blows up the dimensions. So there isn't even the mathematics there today to get a grip on that problem, actually. So that's on a digitalization, so huge of opportunities for research. And on the electrification side, well, it mostly boils down to that we need to get the power to where it's needed. So that means the backbone. So it's the local grid, the regional grid, and the national power grid. And there we have a huge problem. Because right now, I don't see that we are on a trajectory to actually achieve electromobility. Because it's not enough to build a charging station. You need to have the power. And if you can't get 1 or 10 or 20 megawatts where you are, then it's not going to happen. And right now, it really looks a bit dire, to be honest.
That's really interesting. I mean, I am sure that we have many researchers in the audience and online people listening to this. Is a lot of ideas, because when you look at challenges, that's where actually can think and start a research, I would say. And now, follow up on this question, I ask you, okay, we have heard about challenges. What areas to focus, or how we can accelerate this shift, if you want to help researchers to accelerate this shift?
Well, to be honest, I personally find it a bit difficult to pinpoint one area to focus on to accelerate the shift. One common denominator is perhaps that we all need to have a high degree of, adaptation, be adaptive given the speed at which things are being changed and all of the unknowns in the future. But to mention a few, I think kind of culture, education area, overcoming established habits, norms, while at the same time raising the awareness can be daunting. And I think success in digitalization, reduction in energy consumption, what have you, kind of requires both the producer on the one hand side, the end user on the other hand side, not only to understand the kind of how piece, but also have the willingness to change these established norms and the corporate cultures. Another area would be kind of policy and regulatory requirements, to have the financial incentives to adopt to electrical vehicles, investing in renewable energy, implementing smart technology in buildings and industry. And finally, I would say, continue to invest in and develop various infrastructures, like the charging infrastructure, the electrical grid, and also connectivity and high-speed internet, etc.
Great. So I take this last few minutes by asking a question that probably many of the audience are also thinking, because you are from the industrial focus of your companies are completely different. Xylem with the development of electric motor for water pumps, and Scania more known. But I start with you, Rino. What is the role of Scania in this shift?
Right. Scania has committed itself really fully to driving this shift. It's even a slogan from us. And just to give one number, by the end of 2030, we are aiming at selling 50% of all sales only electrified vehicles. So 50% is electrified vehicles. That's quite a lot. But that really, just to get it down, we need that infrastructure. And it's not about the charging infrastructure, it's about the backbone. We need the power grid to keep up with the speed we are rolling out electromobility. Otherwise, nobody will buy it. So that's one thing. To help along with the charging infrastructure, Scania is part of the TRATON Group, and TRATON Group, together with Volvo Group and Daimler Trucks, have established a joint venture. So we will roll out Europe's largest and best charging network for heavy-duty vehicles. But again, if we can't connect the charging stations to a power grid, they won't use it. No use of that. We are also looking at a lot of electrified roads, so electric road systems like dynamic charging will actually help the grid, because instead of like a hotspot, here you need 20 megawatts and you use it only during lunch, you sort of distribute the power demand along the road and during time. So we looked quite a lot at how we can electrify roads, so continuously driving vehicles electrically. And then in terms of digitalization, I said data, models and algorithms, we are on all those topics, and I said the math isn't really there to actually attack the problem, but there we are in research. For instance, we have a project together with Linköping University, with a mathematical institution, really to deep dive into what can be done there.
So being also from Scania, so I would say that also you mentioned that Scania approach is to technically look to the future and try to provide this culture by offering the technology. That's what you meant, because I mean the culture that you mentioned, Jan, was really important, because it's one of the challenges and also one of the focuses, I would say, because just if the culture is not there, if the technology is not there, no one uses what we offer, basically. And then I asked the same question, like maybe Scania is more known to the audience, our product is more known, but talk a little bit about Xylem and how Xylem, what is the role of Xylem in this?
Yeah, kind of the company I work for, Xylem, is a global water technology company that provides or offers comprehensive solutions for the entire water cycle, from the kind of the water intake, treatment of water, the usage of water, etc. And kind of the role I think we as a company can take is to act or be a thought leader in our industry, and when it comes to digitalization and energy reduction. Roughly 20% of the global electricity demand goes into pumping systems. So it's a large number, and the kind of the products we develop here in Sweden, and to a large extent also manufacture here in Sweden, the installed base there roughly consumes 0.1% of the global electricity being produced. And so how we as a company together with our customers can implement smart solution and reduce the energy really do matter. If we were to kind of leverage the latest technology and optimize how our products are being used, we could definitely generate enough savings to shut down one or even more nuclear reactors. And looking forward, I'm very excited to be part of that journey. I think we have a lot to do in front of us, a lot of good things to do in front of us.
Wow, these numbers were really interesting to hear. By this, I thank you. If there is any other point that you want to add that I probably didn't point out.
There's a question from the audience.
Yes.
Can I ask it to John?
Yes, please do that.
Do you at Xylem also work with proactive actions instead of reactive actions when optimizing energy and water flows? Is a question from our audience.
So proactively, I guess, how shall I say, we traditionally, historically, we've had pumps, for instance, that it's on-off, one speed, on-off. Now, and you know, it's kind of the user that, to a large extent, decides when to operate it. Nowadays, given the new technology we have, we can allow the equipment and also with the monitoring control to make kind of smart decisions to
And be more predictive.
and also then if you know that with the new models, you know, rain will come. Yeah, rain will come. And then you can start preparing your system for that. So that's kind of perhaps an example of being proactive. So by the time it comes, you've made sure you've created the sufficient capacity to handle that additional of, you know, incoming water. Yeah.
Thank you. That was all the questions for this panel. Thank you, panelists, for joining. Give them a warm hand.